Okay, guys, hope you're doing well. Let's go ahead and start section 7.3, which is talking about law of cosines. And so, like last time, we talked about law of sines being used to solve for non-right triangles. Law of cosines is also used to solve for non-right triangles whenever we are either given all three sides or two sides and an angle, and the angle that we're given is between the two sides that we're given. So that might be a scenario that we have, or we might have something like this where we have those two sides and that angle, okay, whatever the case may be. Or obviously side, side, side would be if you were given all three sides of the triangle. So here's the formula, and I've written it in sort of a helpful way, I hope. Opposite side squared is equal to adjacent 1 squared plus adjacent 2 squared minus 2 times adjacent 1 times adjacent 2 times the cosine of theta. And so when you write this formula, everything is determined by which angle you're either given or which angle you're trying to find. So for example, if I'm given or trying to find angle capital A, then on the other side of my equal sign, I've got to have the opposite side of capital A, which would be little a. And then the other two sides will get filled in here. So I'll have b squared plus c squared minus 2 times b times c times the cosine of A. Or let's say that I had cosine of capital C, then on the left-hand side of the equation, I would have to have c squared, and that would have to equal to b squared plus a squared minus 2 times b times a. Okay, so those are just some examples of what the formula may look like. The law of cosines is a special case of the Pythagorean theorem, because if you think about it, in a right triangle, that C is 90 degrees, and cosine of 90 is 0, which would make that term go away, and so you'd just be left with c squared is equal to b squared plus a squared. So this is a generalization of the Pythagorean theorem, which you don't necessarily need to know, but it is interesting to know that that's the case. Okay, so example 1, we're going to just be finding one value from a triangle, and so we're given these three pieces of information in letter A. We're asked to find side B, and so that means we're going to have to use the formula that has b squared on the left-hand side. So b squared is going to equal to c squared plus a squared. Whoops, let me back up here. C squared plus a squared minus 2 times c times a times the cosine of the angle opposite of little b, which happens to be capital B, so that would be 60 degrees. Now, this is what I call the easy calculation, and so what I mean by that is that in order to solve for b, all you're going to have to really do is take the square root of both sides, okay? And so this is going to end up being, when you type this into the calculator, and I would go ahead and just do it in one line on your calculator, you're going to get 4.6 if you round to the nearest tenth. Okay, example letter B right over here is going to be very similar to example A. So I'm going to give you a chance to pause the video now and try example B. Okay, and now that you've tried example B, let's just double check that you got C is equal to 5.1, and your setup should have looked like this. C squared is equal to 7 squared plus 6 squared minus 2 times 7 times 6 times the cosine of 45 degrees. And then just take the square root of that big long expression, and you end up getting 5.1. Okay, letter C and letter D are the somewhat more complicated calculations, and so I'm going to walk through this one with you. Letter C, we want to find capital B, and we are given all three sides, and so the fact that it's side, side, side tells me that I'm going to use cosines. And so the version of the law of cosines that I'm going to have to use is the one where we have cosine of B. So cosine of B is going to be right here, and that means that little b needs to be on the left-hand side of the equation. So this is going to say 4.58 squared is equal to 4 squared plus 5 squared minus 2 times 4 times 5. Now, you could start calculating these numbers, and there would be nothing wrong with that. I, however, find it easier just to do the algebra without calculating the numbers and then just punch it all into the calculator at the end. So let me explain what I mean by that. The first thing we need to do to get cosine of b by itself is we need to move these two things over to the other side. And so when we do that, we're going to subtract. And we're always going to subtract those two numbers to the other side. So 4.58 squared minus 4 squared minus 5 squared is equal to negative 2 times 4 times 5 times the cosine of b. Okay, the next thing we would need to do is move this to the other side. And since all of that is being multiplied, then to move it to the other side, we are going to divide. So I'm going to divide both sides by negative 2. Please don't forget the negative. That's sort of one of the most commonly forgotten things. And so what this means is that cosine of capital B is going to equal to 4.58 squared minus 4 squared minus 5 squared divided by negative 2 times 4 times 5. And so now to get capital B by itself, I need to get rid of cosine. And of course, the opposite of cosine is cosine inverse. And so we're just going to do cosine inverse of that fraction. In your calculator, I would highly recommend using the alpha y equals enter trick to do a fraction. Make sure that you're in degree mode. And what you should end up with is 60.0 degrees. Okay, so double check in your own calculator that you would get that if you were to type that in. I'm going to let you try D by yourself and then come back here in a minute and see if you got the correct answer. Okay, on letter D, our correct answer is going to be 45.0 degrees, and this should have been your setup. You should have started on the left-hand side with 7.33 squared and set that equal to 9 squared plus 10 squared minus 2 times 9 times 10 times the cosine of A. And to get cosine of A by itself, first thing is to subtract these two things to the other side. And so that would have given you 7.33 squared minus 9 squared minus 10 squared. And then the next thing would have been to divide by negative 2 times 9 times 10. So divided by negative 2 times 9 times 10. And I'm going to erase this and just make it look a little nicer just so that it's a little bit more clear. Cosine of A is equal to that fraction. And so to get A by itself, we would take the cosine inverse of that number and end up with 45.0 degrees. Okay, so please let me know if you have any questions on either of those types of calculations, either A or B, which is where all you have to do is take the square root, or C or D, where you have to do some algebra in order to get the answer. Okay, in example 2, we're going to solve the triangle, which means we're going to find all the missing angles and sides. Now, in letter A, we're given A, B, and capital A, side B, and side C. So if we let this be our triangle, we're given capital A right here. We are given side B, which is opposite of angle B, and we are given side C, which is opposite of angle C. And so what you realize is that this is side angle side, which means that we're going to use law of cosines. So the first thing that we're going to do here is really the only thing that we can do, and that's to find little a. So to find little a, we're going to set up our equation with little a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of capital A, which is 33 degrees. And in order to get a by itself, all we need to do is take the square root of that number. And when we do that, what we end up with in the calculator is about 7.16, etc. But if we're rounding to the nearest tenth, we're going to call that 7.2. But when we do future calculations, we are going to need to use this number right here. So keep that in your calculator. You can store it if you want to do that, if you have your own calculator at home. there is a button down by the on button called stow, and then you can store that in A if you want to and recall it that way. And the way that you would get to A is you would do alpha and then A, which I believe is above the math button, if I'm not mistaken. I don't have my calculator sitting right here, but I believe alpha math is how you would get to A to store that, and just hit enter, and then the calculator will store that. And then you can recall it by hitting alpha A again in any future calculations. Okay, if you don't understand all that, no worries. Just go back up and grab A whenever you need it. Okay, the second thing we're going to do is we're going to find the missing two angles. And we're going to find the biggest angle first, although honestly it wouldn't really matter a ton. But the bigger angle is going to be the angle opposite of the bigger side, which is C. Since C is bigger than B, we're going to find angle C first. So I'm going to start this off with C squared, which is 13, is equal to my B squared, which is 12, plus my A squared, which is 7.2. And I'm really just writing that as a placeholder. But I know that I'm going to use 7.16, etc. when I write this in my calculator. 7.2 cosine of capital C. Okay, and doing my rearranging, this would be like our second calculation from example 1, like we did in letter C and letter D. We're going to start by subtracting over those squares. So start with the left-hand side, subtract the two squares, and then divide by the number that's in front of cosine. So that would be negative 2 times 12 times 7.2. And so capital C is going to equal, in this case, 81.2 degrees. Okay, and here's my letter A. Step 3 is to find the one missing angle, which would be angle capital B. And since we now have the other two angles, we can just cheat a little bit here and subtract the other two angles that we have. And so if we do that, we're going to end up with 65.8 degrees. Okay, let me know if you have any questions on that problem. On letter B, we're given all three of our sides. So all three sides means we are going to use the law of, oops, sorry about that. Let me get the notes back. We are going to use law of cosines. And we're going to find the biggest angle first. And the biggest angle would be the one that's across from the biggest side, which is going to be capital A. So the first thing we're going to do is find capital A. And so what I know is that we're going to start with the version of the formula where A squared is on the left-hand side. So 6 squared is equal to 5 squared plus 2.5 squared minus 2 times 5 times 2.5 times the cosine of capital A. And rearranging that so that we get A by itself, we're going to have cosine inverse of, starting with the left-hand side right here, 6 squared, subtracting over these two squareds here. So that would be minus 5 squared minus 2.5 squared, and then divided by my negative 2 times 5 times my 2.5. And punching that into the calculator, we're going to get 101.0 whenever we round to the nearest tenth. I don't think that's quite what you get whenever you leave it unrounded, so don't round it just yet. We're going to wait till the final to round it. Keep that number around in your calculator. Okay, we're going to find the next biggest angle next, so that would be B, since that's the next biggest side. So we're going to find capital B now. And so that means we're going to set up the formula so that B squared is on the left. So 5 squared is equal to 6 squared plus 2.5 squared minus 2 times 6 times 2.5 times the cosine of capital B. And doing the rearranging algebraically, cosine inverse of, starting with the left-hand side, 5 squared, subtracting over the two squareds, and then dividing by the number in front of cosine. So negative 2 times 6 times 2.5. Sorry for the bad handwriting there in the numerator. This 2.5 should be a square. There we go. And so B is going to equal to, when you punch that in degree mode, you're going to get 54.9 degrees. Okay, and so step 3 is going to be finding the final side, or sorry, the final angle. And since we have the other two angles, we can just subtract from 180. So 180 minus A minus B is going to give me an answer of 24.1 degrees. Okay, in example 3, we're going to solve the triangle using either law of sines or law of cosines. Okay, so what will make your test somewhat challenging is that you now have to decide, am I supposed to use law of sines or am I supposed to use law of cosines? Well, I know from the previous notes, law of sines is either angle, angle, side, angle, or side, side, angle. And law of cosines is everything else, either side, 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 or side, angle, side. So the first thing you're going to have to determine is which scenario are you in, and then go based off of that. Okay, so in example A, we have capital B, capital C, and lowercase b. So if I draw just a quick triangle here, call this A, B, and C, we are given angle B, angle C, and little b, which is here. And so I see that I have angle, angle, side, which is going to be law of sines. Okay, so remember from previous notes, in order to use law of sines, I have to have a ratio. Well, if you look here, I've got the b ratio. So the first thing I'm going to do is set up that b ratio, which is 11 over the sine of 39. And in this case, I'm going to set it equal to the c ratio because I was given angle C. So C divided by the sine of 83 degrees. Okay, from last class, remember that we're supposed to cross multiply and divide here. And so what you should end up with is 11 sine of 83 divided by the sine of 39. And so little c is going to equal to, in this case, 17.3 if I round to the nearest tenth. Okay, next thing is to find angle capital A. So to find angle capital A, we know that we can subtract 180 minus the other two angles, B and C. And if we do that, we're going to get 58 degrees. So that was pretty straightforward. Easy to find capital A. We actually could have done that first if we really wanted to. And now the last thing we need to do here on example A is we need to find side little a. So again, I'm going to use that given ratio, 11 divided by sine of 39. I'm going to set that equal to the a ratio, which is little a divided by sine of capital A, which I figured out was 58 degrees from step 2. And cross multiplying and dividing should give you 11 sine of 58 divided by the sine of 39, which will give you an answer of 14.8. As long as I'm looking at my notes correctly, and I believe I am. Yeah, 14.8 will be side little a there on example A. Okay, on B, we are again given two angles and a side, and so that's pretty much a dead giveaway that it's going to be law of sines if you're given two angles, because if you look here, the only two scenarios where you're given two angles are both law of sines. So this is pretty much a dead giveaway that you're going to have law of sines going on here. Notice, though, that I don't have a ratio yet. I have angle B and angle C, but I don't have either of those sides. I actually have side A. And so I'm technically given a ratio here, but I'm not given a ratio, if that makes sense. The first thing I'm going to have to do is I'm going to have to find angle capital A so that I can get a ratio. So capital A is going to equal to 180, subtract the other two angles. And so when I do that, what I'm going to get is 74 degrees. And so now I have a ratio. So that was step 1. Step 2 is now I need to find the other two sides, and it really wouldn't matter which one you found first, because in each case you're going to use the A ratio that you were given, which is 15 over the sine of 74. I'll just set that equal to the B ratio first, since, you know, alphabetical order and everything. Okay, so B divided by sine of 33, and when you cross multiply and divide, you're going to end up with B is equal to 8.5. So just double check that you get 8.5 there as your answer for B. And then For step 3, I'm going to again use that given ratio, 15 divided by the sine of 74. And I'm going to set that equal to the C ratio now, which will be C divided by the sine of 73. Cross multiplying and dividing will give us the answer for C, which will be 14.9 if we round to the nearest tenth. Okay, in letter C, notice immediately that I'm given a ratio. That's also pretty much a dead giveaway that this is going to be the law of sines. Okay, but I'm just going to double check here. So A, B, and C. And what we're given is capital A. We're given side A, and we're given side B there. Oh, sorry, that's not side B. This is side B. Okay, either way, the case remains. This is side angle. Now, remember from last class in section 7.2, side angle is that one case that's a little more challenging because this could either be one triangle or two triangles or even possibly zero triangles. And so we're going to have to determine that just based on our work. And so if it's okay with you, I'm going to go ahead and erase this just so that I can have a little bit of extra room to work here. And we're going to start by setting up this A ratio. So 10 divided by the sine of 7 degrees. And I'm going to set that equal to the B ratio, which is going to be 11 divided by the sine of capital B. Okay, if we cross multiply and divide, we're going to get 10 times the sine of B is equal to 11 times the sine of 7. Which means that B is going to equal to, I'm going to go ahead and do the sine inverse here of 11 sine 7 and then divided by 10. Okay, so I had to divide by this 10 here to move it to the other side. And what you end up getting is an answer here. And the answer that you get is 7.7 degrees. And so the fact that we got an answer tells me that there is at least one triangle. And so I'm going to go through and I'm going to solve for this first triangle, and then I'll determine a little later on if there is a second triangle. So now I have A, I have B1. I'm now going to find C1 by subtracting 180 minus A1 minus B1. And so that is going to give me an answer of 165.3 degrees. For angle C sub 1. And then the last thing is to find little c sub 1, so the side c sub 1. And so I'm going to set that ratio up, c sub 1 over sine of c sub 1. And I'm going to set that equal to my given ratio, which is 10 over the sine of 7. Cross multiplying and dividing is going to give me c sub 1 is equal to 20.8. Okay, I am now ready to start and see if there is a second triangle. So I'm going to start from that B1 that I calculated, and I'm going to say that B sub 2, if there is a B sub 2, would be 180 minus that 7.7. And so 180 minus that 7.7 would be 172.3. Now, if I add that to the given angle, which the given angle is right here, A is 7. If I add that to 172.3, that number is going to be smaller than 180. So 172.3 plus 7 actually gives me 179.3. And that number is smaller than 180. And so that means we are going to have a second triangle. So I'm going to go ahead and box this as my answer for B sub 2. C sub 2 then is going to equal to 180, subtract A sub 2 and B sub 2. And this A is equal to 7 is not only my A1, but it's also my A2. And so this is going to give me a really tiny angle of 0.7 degrees. Okay, so really tiny angle. It is going to be a second triangle, but it's going to be a pretty small one. Okay, and so there's step 1 for triangle 2, there's step 2 for triangle 2, and step 3 for triangle 2 is to find little c2. So little c2 divided by sine of capital C2, which is 0.7 degrees. I'm going to set that equal to my given ratio, which, going back to my original work, is still right here, 10 divided by sine of 7. And cross multiplying and dividing is going to give me C2 is equal to, again, pretty small side there, 1.0 when you round to the nearest tenth. Okay, so I did 3 more examples there on the law of sines. I did that really because law of sines is a little more challenging than law of cosines. But if you need some extra practice on law of cosines, please feel free to reach out and I'll be happy to help. Hope you guys have a great day.